Hello everyone, welcome to Quantum Guruji. So today in this video we are going to see how to design a heterostructure or a composite material and what are the ways of designing this kind of lattice. So right now I have taken one lattice of zinc, indium and sulfur, that is Zn, In2 and As4. So this lattice I have taken, you can take any lattice whatever you want. Okay, so to design a heterostructure or a composite material, you need to know the most reactive surface of that material. For that, you can dig in the literature, or what you can do is, if you don't have any literature value, generally you will be having use literature. You can go and dig the details, and so that you can cleave the surface to that specific plane. Or in case you don't know the plane, what you can do, you can cleave the surface in various planes like 110, 001, 010, all the planes, and check it out which is having lowest energy and use the surface for your cleaving. Now right now I am having this lattice, okay, and just for example I am just cleaving this surface because I need to create a heterojunction. So my aim here is I want to create a zinc indium sulfur surface, and on the top of that I want to put a graphene oxide lattice. Okay, so that is my composite material that I am going to create here. Okay, so this is the lattice here. Now I will cleave it. So I know that for this system the most stable surface that is given in the literature is 110 surface. So what I can do is I can go to the build menu, and there I can go to the surface, and in the surfaces, cleave surface. In the cleave surface you just put your Miller indices here, that plane, which plane you want to cleave. So my interest is 110, so I'll put 110 here, and the thickness of the plane. Okay, so thickness of the plane is it means, suppose this is your cubic lattice, right? This lattice here. Okay, now you can cleave, the thickness can be this much, or this much, right? That cleaving thickness, it depends, but generally how much we have to take the thickness, it's like, it's not up to you. Generally you should take at least 4 or 5 atomic layers, okay, so that you can have a good amount of atomic interactions, and that is generally a decent the surface thickness you should consider. So in case you don't know like what is the thickness that you want to cleave, just give some random value here and cleave it. Okay, and once you cleave, you will see a surface here. Okay, now go to right click, go to the display style, and put a black color to the unit cell, the lattice, choose black. Okay, so now you can see this slab. So it's a huge slab, right? Since I have given the thickness, that is a 3 unit, but I don't want this much thickness. I just want like 4 or 5 atomic layers. So I will start decreasing the values here, right? You can see the layer thickness is decreasing. Okay, I want, oh, not this much, I want certain more layers, some decent, yeah, maybe this much. Okay, so it is like 1 atomic, 1 2 3 4 5, right? So this is 5 atomic thickness that I have taken here. Okay, now this is the slab. Now we need to have some vacuum space. Vacuum spaces means, now this is a 2D slab, right? And the calculation will be performing in a 3-dimensional surface space. And to put another layer like that will be the graphene oxide, we need to have some vacuum space here, right? So what we'll do is, now we'll go to this tools menu, build menu, crystals, build vacuum slab. Okay, now here you can give some vacuum. This is the thickness of vacuum. So what is the way to select the thickness? Suppose if you want to study a a 2-dimensional system, or just the downs, like in my case I am having zinc indium sulfur. So that zinc indium sulfur and that graphene oxide, so I want to study this, just these two interaction, means it's a 2-dimensional system, right? So what I will do is, I don't want the third dimension here, I don't want third dimension. So In that way, I will keep this thickness huge so that there is no interaction between your, the plane of your lattice and the third dimension. I will take 20 angstrom build. Now you can see here, right? The third dimension, this C is quite long, so that there will be no interaction in the third dimension, and we have this slab. So it depends, like in case you want to study the slab, so you can decrease the thickness or the vacuum surface. So it's up to you depending on your calculation in the system. Just I'm giving you an example. Okay, so we have designed, we have cleaved the surface of this Zn ion S2 twice lattice in a 110 plane. Now we want to put graphene oxide on above this slab. Okay, before that we need to design a graphene oxide. So just I have approximated a graphene oxide structure. Okay, this is not the real structure of graphene oxide. Okay, because graphene oxide structure is still question or debatable depending on your oxidizing agent or the process of manufacturing. You will get different structures. I have just approximated a graphene oxide structure. Okay, and if I see the like what is the dimension of this lattice, if I see here, it is around 11 angstrom, and this way is around 10 angstrom, right? So I will consider 12 in this and 10 in this. That will be the decent dimension of this lattice. So we need to have our 110, this surface. Now we'll check this, what is the lattice parameter. So here x and y is x is 10 and b is 7, means like our molecule will not fit into this, right? So we need to have such a size of your slab so that those graphene oxide molecules should not interact. Suppose I just what I can do is just give a 2 into lattice, right? 1 into 1. Now I will make it 1 into 2. This I will increase in this way. Okay, and I will make a supercell. Okay, see, now this length is sufficient to put your that graphene oxide moiety, because if you see the lattice parameters 10 angstrom and 15, so it is exactly, it will fit in this rectangle, right? But the thing is, if you are going to put this, that graphene oxide molecule will take entire area of this. So what will happen is, when you are when you see these graphene oxide molecule will interact with the neighboring graphene oxide, that will create sometime problem. So to avoid all those things, what you can do is, I will take a bigger lattice of this, means the bigger slab. So right now I'm taking one more unit of this, means the initial we had 1 into 2 lattice. Now again I am increasing that 1 into 2 lattice to one more layer, not this way, I am increasing in this direction. Okay, and then I will make a supercell. See, now this lattice, now I will make supercell. Okay, fine. Now I will go to this graphene oxide, and I will copy this, Control A and Control C, go back to this planar slab, Control V to paste, or you can paste by just clicking this paste. Select your molecule and put on the slab properly. For that, use movement tool here. And rotate this, make it on the planar surface. Fine. Okay, now we need to rotate it again. Okay, now if you see our graphene oxide moiety, now make it down. So it should be not huge down, there should be some kind of interaction. And now we have this graphene oxide lattice above, and you have this whatever, suppose you are having zinc oxide, any metal oxide, or any surface you are working with. Here I am using this surface, right? So I have kept this graphene oxide lattice on this. So I have created a composite material uh, with graphene oxide and this zinc indium sulfur. Fine. So similarly, you can use anything and you can create your own material or any heterojunction system. Okay, so we are having a heterojunction here, right? Two different materials are connected here on the surface. So we call them a heterojunction also, right? And a composite material. Fine. So this is the way we can design a composite material. Now you can go to this symmetry and impose the symmetry. Most of the cases you will be getting P1 because you having this non-periodic system here which is having a C1 symmetry. Fine. And overall you will be getting the C0 symmetry, and you can optimize or whatever calculation you want to perform, you can go ahead with that, right? So if you have any doubt pertaining to this video regarding this composite material designing, you can put in the comment section. Thank you for watching the video. Don't forget to like and subscribe the video.